right, today we are going to talk about right triangle trigonometry. So the majority of what we're talking about was a review from what you learned first in Algebra 1 and then really focused a lot on at the end of geometry. So you learned 3 of your 6 trig functions in geometry. You learned sine, cosine, and tangent. In Algebra 2, we are going to be adding their reciprocals, which are cosecant, secant, and cotangent. So in geometry, you learned the phrase, or I guess acronym, SOHCAHTOA. So SOHCAHTOA. And what SOHCAHTOA helped you remember was how to come up with the correct ratios for each trig function. They're all ratios, meaning one part of a right triangle divided by the other is how we define them. So the sine of an acute angle, again, it's important that we understand it's acute. Sine of an acute angle is going to be the ratio of opposite side to the hypotenuse. So that is why when we have SOHCAHTOA, the S stands for sine, and then the OH tells us which of the pieces are going to form its ratio. So opposite over hypotenuse for sine. Cosine, so here's cosine, is AH, so it's the adjacent side over the hypotenuse. And then the tangent, T over here, OA, is opposite over adjacent. Now, those are the 3 that you should be very familiar with, that you've learned several different times. Cosecant, secant, and cotangent are new, but the concept isn't new. They are just the reciprocals of our originals. So, cosecant of theta would be, if I reciprocal sine, hypotenuse over opposite. Now, if you're not actually looking at the triangle and you're just given the sine value, you would find the cosecant by doing 1 divided by the sine of theta. So 2 different ways to come up with the cosecant here. Secant, again, is going to be the reciprocal of cosine, so hypotenuse over adjacent if you're looking at the actual sides of the triangle, or if you're just given the cosine, 1 divided by the cosine would give you the secant. And then finally, our cotangent is going to be adjacent over hypotenuse, or opposite rather, sorry, adjacent over opposite, or 1 divided by the tangent of theta. Now, it's really important that you know which ones go together. It's easy to do the tangent and the cotangent, but for some reason people always mess up the sine and cosine and which ones go with it. A good way that I like to remember it is that every pair has to have a co, because they're partners, so they're co-workers. So every pair has to have a co. So since sine doesn't have a co in it, it goes with cosecant. Cosine has co, so it goes with secant. Tangent does not, it goes with cotangent. So hopefully that will help you remember which ones go together. The rest of what we are doing should be review. So we are looking at special right triangle formulas, a 45, 45, 90 triangle. So if this is 90 degrees and these are both 45, that means that these 2 sides are the same. We call those the legs, and we call this, of course, the hypotenuse. So whatever the legs are, so let's say if the legs are 1, then your hypotenuse is radical 2 times that, which is what our formula says. So this one I've got 1, 1, radical 2. But if this was 3, 3, this would be 3 radical 2. So the hypotenuse is equal to the leg times radical 2. In a 30, 60, 90 triangle, you have 2 different formulas because there's 3 different sides. lengths because there are 3 different angle measures. So 1 is what we use to stand for the short leg, and the other 2 sides are based upon the short leg. The hypotenuse is the short leg times 2, so in this case 1 times 2 is 2, and the long leg, which is across from the 60, is the short leg times radical 3. So 1, 2, radical 3 if you count them. So first thing you're going to be doing is evaluating the 6 trig functions when they give you a picture of a triangle and they give you the angle theta. So here's my angle theta. It wants me to find all 6 trig functions. So that means I am going to need the sine of theta, the cosine of theta, the tangent of theta, and then all of their reciprocals. So I will need cosecant of theta, secant of theta, and cotangent of theta. Now, in this picture, I only have 2 sides. The very first thing you need to do whenever you're evaluating these trig functions is find the missing side. So we can do that with the Pythagorean theorem. So 9 squared equals 6 squared plus x squared, if this is the side we don't know. So 9 squared is 81. 6 squared is 36. So if I want to solve for x, I'm going to subtract the 36 first. So 45 equals x squared. And then I'm going to square root both sides. Now in trig, unless it says otherwise, you are going to leave your answers in simplest radical form, which means no decimals. So if I factor tree the 45, it's 9 times 5. So 3 radical 5 is what that missing side is. So I'm going to write that in blue here so that when I look at my theta, I can just look at all 3 sides together. So if I want to do sine of theta, here's theta. Sine is opposite over hypotenuse. So opposite means across. So 3 radical 5 over hypotenuse, which is 9. And then, of course, we would simplify. So simplified version, reduce the 3 and the 9. So radical 5 over 3. Cosine of theta. Adjacent side, which is the 6, over the hypotenuse, which is 9. That one's easy to simplify. That just becomes 2/3. Tangent, opposite over adjacent. So opposite is 3 radical 5. Adjacent is 6. Again, I need to reduce. So that gives me radical 5 over 2. All right, now when I do the reciprocals, in some cases, it's easier to reciprocal the answers. In others, you may want to reciprocal the work. It does not matter. That's why I wrote both of them up here. So cosecant here, if I'm going to reciprocal the sine, I would get 3 over radical 5 for my cosecant. I cannot leave it like that. That's not simplest radical form. I have to rationalize. So multiply the top and bottom by radical 5. So 3 radical 5 over 5 is going to be my cosecant answer. Secant is easy when you reciprocal it. There's no even work to do. 2/3 reciprocal is 3/2. Cotangent, I've got a reciprocal radical 5 over 2, so 2 over radical 5. And again, I have to rationalize because I need my answer in simplest radical form. So 2 radical 5 over 5. So there are my 6 trig functions. Example 2, find the missing side lengths. You can see here that these are special right triangles. I've got a 30, 60, 90. I've got a 45, 45, 90. So first thing I need to do in A is decide which of the sides I'm being given, because that's going to make a difference as to what formula I use. So since this is the 90-degree angle, I have what's across from it, which means I have the hypotenuse. If you look at your 2 formulas, the only one that has hypotenuse is this one. So I have to use hypotenuse equals short leg times 2. So hypotenuse is 7. Short leg, the short leg would be across from the 30-degree angle, so that's x, times 2. So if 7 equals x times 2, divide both sides by 2, and x is 7/2. Just like we're going to do simplest radical form, we also do simplest fraction form. So 7/2 is my x value. Now I need to find my y value. Y is my long leg, so I have to use this formula for the long leg. So long leg, which is y, equals short leg times radical 3. So y equals short leg, which was the x, so 7/2, times radical 3. So now it's just fraction multiplication, top times top, bottom times bottom. Y equals 7 radical 3 over 2. On B, this one is a 45, 45, 90. So again, look at which part you have. It's only one formula. We know we're going to be using hypotenuse equals leg times radical 2, but it matters which side we have. So I look here. I've got the hypotenuse again, so I put in radical 15 for the hypotenuse. Leg, it doesn't matter whether I put in x or y. They're both the same. So here's my equation. In order to solve for x, I need to divide both sides by radical 2. Now, 15 and 2 don't have common factors, so I can't reduce that, but I do need to rationalize it. So multiply top and bottom by radical 2. So x, which is the same as y, so I'm going to go ahead and write them together, is radical 30 over 2. Because I know that they have the same measure. All right, example 3, we are finally going to look at the calculator. And we need to make sure that your calculator is in the right mode. So your mode button is right, not in the very top row, but in the second to top row, just next to your second button. So find the button that says mode and press it. And in the third row down, so you should see like normal, float underneath it, and then you should see radian, degree. We want to make sure that this is what is darkened. If it's not, you need to scroll down to it and press enter over top of the degree, because degree needs to be the darkened mode right now. All right, so once you know that it's in the right mode, now it's just a matter of mostly pressing buttons. So if I want to know the sign of 17, I just press sign, 17, close my parenthesis, and press enter. Here it says we're rounding to 4 decimal places, so that would be 0.2924 because the last digit has to round up. Now, B says cotangent of 11. I don't have a button that says cotangent, but I do know that cotangent is 1 divided by the tangent. So that's how I have to evaluate those reciprocal functions. So I need to press in 1 divided by, put parentheses around your tangent to make sure that it's not going to mess it up. Press 11, close both the parentheses, and then press enter. If you do not get the same answer as me, that probably means you didn't do your parentheses right. So try it again, putting parentheses around here, and see if that fixes it. If it doesn't, please see me in class so I can make sure you know how to press this in. All right, so now that we've got the calculator out of the way, we need to review one thing. My triangle didn't show up. It's on my paper, but for some reason it is not on here either. So excuse the very sloppy looking triangle. Let's pretend that that's not crooked. It says solve triangle ABC. This is a most common mistake in geometry and on this unit test. When it says solve, that means find every missing angle and side. So, first thing I'm going to do, you don't have to, even though it's not stated, you don't have to state that angle C is 90 degrees because that is marked. But I do need to find angle A. So I know that if this is a right triangle, that the measure of angle A has to be 90 take away the 62. So the measure of angle A is going to be 28 degrees. Now, I'm sure that your geometry teacher taught you this, but I just want to review this. When you are solving a triangle, if possible, you should always use the measurements that they gave you, not one that you calculated. Because if you calculated something wrong and then you use it to calculate something else, now instead of one thing being wrong, you've got additional things that are incorrect. So please, 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 there are some cases where you can't help it, but if you can, please use the information that they gave you. So we're going to use here, the B is 62, and again, sorry, my drawing doesn't look 62. And then we know that side A is 6 units. So I already found the missing angle. I need side B and side C. So I can base that all off of my 62 and my 6. So I need to form trig ratios. So if I want to find B first, in relationship to the 62-degree angle, side B is the opposite side. The 6 is the adjacent side. So when I set up a ratio here, I am going to use the one that has opposite and adjacent, which would be tangent. So tangent of 62 equals opposite, which is B, over adjacent, which is 6. So to solve for B, I would multiply both sides by 6. Those would cancel, so B is going to equal 6 times the tangent of 62. So you can press that right into your calculator here. So 6 times the tangent of 62, hopefully, it doesn't say on these ones what to round to, so here we're going to go nearest tenth. It's about 11.3. Now again, I don't want to use that 11.3 because it, first of all, is rounded. And when we use things that are rounded, it makes our answers off. So we don't want to use the rounded figure. We want to find C based upon the 62 and the 6 because we know those exact values. So C is the hypotenuse. 6 is still the adjacent. So the ratio that uses adjacent and hypotenuse is cosine. So I'm going to set up a cosine of 62 equals adjacent over the hypotenuse. So over here, the variable was on the top. Over here, the variable is on the bottom. When the variable's on the bottom, you would have to multiply by C. That would cancel these. You'd have C times the cosine of 62 equals 6, and then you would divide by the cosine of 62. Now, most people notice a pattern here. Whenever the variable's on the bottom, you can switch it with the trig function over here. So when I'm solving for C, C equals 6 divided by the cosine of 62. So I can press that into my calculator, put parentheses around the cosine. You should get C to be approximately 12.8. And now our triangle is solved. We know all 3 angle measures. We know all 3 side lengths. So last example, you're standing at the end of the shadow of a giant sequoia 150 feet from its base. If you didn't know, a sequoia is a very large tree, and it doesn't look like this, but I'm not a good artist, so we're just going to draw a tree like this. So here's the tree, here's the shadow it's casting. You are standing at the edge of it, it says, and it says you're 150 feet from its base. So there, you're 150 feet from the base of the tree. The angle of elevation to the top is 63 degrees. Angles of elevation always have a side length with the bottom row, and they go up. So this is an angle of elevation, that's 63 degrees. It wants to know how tall the tree is. So that's X. So example 5 here is like example 4, except you only have to find one thing and you have to draw the picture yourself. I look at what I filled in on my picture based on what I want to find out, my X, and the 2 things that I know, and I set up a trig function. So this 63, the x would be the opposite side. The 150 would be the adjacent. So this is going to be a tangent. So tangent of 63 equals opposite, which is x, over adjacent, which is 150. This is the kind we like, where the variable's on the top. So just multiply both sides by 150. This cancels, and you can press this guy into your calculator. So x equals, and you should get about 294.4 feet. Now, one last thing that I want to point out, because this, I said angles of elevation, they look like this, where it has one of its sides is the ground or whatever the baseline is. You also will have questions like you had in geometry where you have angles of depression, and angles of depression look a little bit different because they're more, I would say, have a side with the sky. So angles of depression, you would draw the triangle like this. So I just want to make sure you know the difference between those two. All right, it ain't easy being a beezy.